Hi folks, this is video 17-4. This is actually the final video for chapter 17. And we're going to be finishing up our survey of reactions and mechanisms under the topic of nucleophilic acyl substitution for carboxylic acids and derivatives. And again, here's our checklist for part 4 of the various reactions under NAS that we have covered. So in the last video we covered ester exchange reactions. Today we're going to be, in this video, we're going to be looking at the conversion of esters to amides. And just one correction here, this is not acid catalyzed. This is actually a uncatalyzed reaction. And we'll see why in just a couple of moments. We will cover that. Saponification we are going to skip, and base catalyzed ester exchange we're going to skip. Notice that acid catalyzed ester exchange, we already covered that. It's just the base catalyzed one that we're not going to deal with. And then the final topic will be acid catalyzed amide hydrolysis, and that will finish up everything under reactions of esters and also everything within this particular chapter. Alright, so let's look at the uncatalyzed conversion of esters to amides. So this is an uncatalyzed reaction, and the reason is that if you use an acid catalyst, you have to ask yourself which reactant is going to end up getting protonated. We always talk about how the carbonyl oxygen is more basic than the alcohol oxygen. However, the strongest base in this case would actually be your nucleophile. So if an acid catalyst were used, you would protonate the nucleophile, which would make it unreactive as a nucleophile. So this is an uncatalyzed reaction, typically done under higher temperature in order to help force the equilibrium. But as it turns out anyway, this equilibrium greatly favors the products. So just change that equilibrium arrow a bit. And once you form the amide and the free alcohol, in order for this to go in the reverse reaction, it really has to be acid catalyzed under those conditions. So this equilibrium greatly favors the products and is about as close to an NAS reaction that's going to go to completion as we're going to see. Okay, so let's look at what the mechanism for this uncatalyzed conversion of an ester to an amide looks like. And since since we are not using any type of an acid catalyst, that means we do not start with any type of a protonation or proton transfer, but we have the nucleophile adding to the carbonyl group directly. Nucleophile in this case being ammonia. We could also use primary or secondary amines, and that will be attracted to that partial positive charge on the carbonyl carbon. Ammonia is a good nucleophile, so that's what helps this first step, which is an addition. And as we see in many of these addition steps, we go from the sp2 to an sp3 type of an intermediate. Negative charge on the oxygen because it's accepting a pair of pi electrons. And the amine, the ammonia that's coming in, is going to have 4 bonds to it, so it's going to have a positive charge. And then we have the original alcohol group. Okay, so there's our initial intermediate that's formed in this mechanism. Now let me copy that and bring it down to the next step. So what do you think is going to happen as we now move into step 2? When you look at this intermediate, I have a feeling that we feel this urgent need to do a proton transfer and to neutralize both of these groups. Now, if you do that, that's perfectly fine. Now remember, we also need to make this alcohol a good leaving group. So technically, it's probably simpler to just skip that intermolecular transfer up here and instead do an intramolecular transfer from the protonated amine to the alcohol that's going to eventually be the good leaving group. Now, as I said, I mean, my gut feeling is I immediately want to grab a proton and neutralize both of these. Okay, that's perfectly fine. Then you're going to have the neutral alcohol grabbing a proton from the protonated oxygen over here anyway. So it really is kind of a wash. But the mechanism here is a little bit unusual in that we don't start with a proton transfer, but we still see this regular alternating series of steps of additions, proton transfers, and then eliminations. All right, so we do this proton transfer in order to make the alcohol a good leaving group. Now remember, I said in the summary part to when we were getting started with NAS is that when you have uncatalyzed reactions, you're going to have intermediates that are going to be neutral, or they're going to have negative and positive charges. So this is not at all unusual here. All right, so now we've neutralized the amine part. We now have our alcohol as a good leaving group, and it's going to do what it should do, which is leave. So let me drag that down here for step 3. So step 3, very simply, we've got the negative charge, the extra lone pair, and the oxygen. We're going to do a typical elimination, as I like to call it. Those electrons come down to form a pi bond, and then the electrons in this bond are going to head toward that positive charge, breaking that bond. And notice that when we complete this elimination step, we end up with our final products. So what we've seen is that when we have acid catalyzed, we have intermediates that are either neutral or positively charged. We have not looked at any base catalyzed or base mediated reactions. We will see those in chapters to come. And here where we have a mechanism that's uncatalyzed, our intermediates are neutral, or they have both a positive and a negative charge. You will never, again, I'll say this again, never ever see a intermediate that has 2 positive charges or 2 negative charges. If you do, you've done something terribly wrong. All right, so there's our mechanism for the uncatalyzed conversion of an ester to an amide. And our final mechanism for this chapter is amide hydrolysis. So when you hear the word hydrolysis, that always means that a bond is breaking, and it's doing so because water is a nucleophile. Now, amides are among the least reactive of the carboxylic acid derivatives. Acid catalysis is absolutely required, and you're going to need both reactions in the mechanisms. And again, the water is your nucleophile. It's coming into an activated carbonyl, and the leaving group is going to be ammonia. This mechanism is very similar to the other acid catalyzed mechanisms that we've already covered in this chapter. So this is going to be another one of the on your own. And at this stage, and I've already seen this in class as you're doing your worksheets, many of you are looking at simply what the reactants are, what the products are, figuring out what the leaving group is, knowing you have to make that into a good leaving group by protonating it, and then looking to see what the nucleophile is, and realizing that that has to come into the carbonyl carbon, and you're going to do a series of proton transfers. So acid catalyzed, just remember, it's going to be proton transfer addition, proton transfer elimination, and proton transfer again. So it's always follow that particular sequence. All right, this is finally a short video, and that pretty much ends chapter 17, and we'll be getting started on chapter 18 and getting ready for the second exam. Okay, that is the end of this recording.